In example 2, we want to find the exact value of the sine of 15 degrees. There's a couple different ways you could do this. You could treat this as a difference, 45 minus 30, and use your sum and difference formulas. But in this case, our objective here is to learn about half and double angle identities. And so I think we'll use one of those. And remember that 15 would just be 30 divided by 2. And then alpha here is going to be 30 degrees. So what we can do is we can utilize our formula. And our half angle formula, if you haven't written them down, there they are. You can pause the video if you need to write them down. So we're going to use the sine one. So the sine is going to be plus or minus the square root of 1 minus the cosine of 30 degrees, all over 2. That's all underneath the radical sign. Remember, we're trying to find the sine of 15. Well, the sine of 15 is going to be the y value here. And the y value is positive. Oops, that's pretty messy. There we go. Positive. So, we don't need this plus or minus sign anymore. We're just going to choose the positive one because the sine of 15 is positive. If you had something like the sine of 200 degrees and you were working with it, well, the sign would be negative there, so you'd want to choose the negative one. Although that wouldn't be a half or a double, I guess, so there's probably a better example out there. Alrighty, so we just need the plus sign, and we're not even going to write it down. Of course, if we don't, we understand that it's positive. We're going to try to evaluate this. This is 1 minus, and then we've got the cosine of 30, which is root 3 over 2, and I'm going to need to extend my fraction here a little bit. And then I've got a 2 here. Now there are lots of different ways to simplify this at this point. One thing we need to be careful of is we have a radical and then we have a fraction underneath the radical. So that's not allowed. This root 3 over 2 is cool, but this root and then a fraction underneath is not. So I think we're going to work underneath first, and I think we're going to try to combine these two here. And so what I can do is I can change this 1 into a 2 over 2. So then I've got 2 minus root 3 over 2 all over 2, and then I like to write that 2 as over 1. I'm going to extend my radical sign a little bit. We're going to bring this up here to this area. Now we can multiply by the reciprocal. So I've got 2 minus root 3 in the numerator over 2, multiply by the reciprocal here. So that's going to be 1 over 2, all underneath the radical sign. And then I've got a 4 here. So this is going to be 2 minus root 3. And I like to do the parentheses because if you have any other value other than 1 here, you're going to have to multiply each term by that value, or at least just keep the parentheses indicating that you'd have to do that. But here we have 1 times this whole thing, which is just that whole thing. 2 times 2 is 4. We can actually do the square root of the numerator and the square root of the bottom. Notice we still have this pesky fraction sitting out here. So now we're going to do the square root of 2 minus root 3, and then all over the square root of 4, which is 2. Now if we look underneath the radical sign, we don't have any fractions. We do have a square root and then another square root, and you would consider that to be kind of nested, is the way people would say that. And then this fraction bar right here is outside of the radical, so we're good to go. And we also don't have a radical in the denominator, so this one is fully simplified as far as our rules go, and that is the value you want to list. You could, if you wanted to, actually check this out and type this in your calculator. So you'd type in the sine of 15, make sure you're in degree mode, and then you'd type in the square root of 2 minus root 3, close those parentheses off, and then divide it by 2, and you should wind up with the same value.